Last class, we learned how to do three variable systems algebraically. Today, we're going to learn how to do those with the matrices. And so as soon as you learn the matrices, you're going to say, oh gosh, that's so much easier because the calculator does most of the work. But remember, we have non-calculator portions as well, so you have to know how to solve them algebraically. But this is an easy way to solve three variable and four variable or so on. By organizing your system into a matrix system, it allows you to put it into the calculator and easily solve. So first we'll start by actually converting it into a matrix system. So if we have a three variable system like this is the way you need to have it as well in the standard form where all of our variables are on one side and our constants are on the other side. So here is our three variable system. We're going to organize that into a matrix equation here. And so we're going to set up a coefficient matrix first, then our variable matrix second, and then our constant matrix. We'll call this coefficient matrix A. We'll call the variable matrix X, since that's what we're solving for is those variables. And then we'll call our constant matrix B. So we set that up as A times our variable X equals B. So we're going to start practicing to get that into the correct format. So the first thing I look at when I have this example here is that my 2y and my negative 3z on this second equation are on the wrong side of the equal sign. And on my first equation, the 5z is on the wrong side of the equation. So the first thing I want to do is make sure they're all in the standard form. They do have to be in the standard form to do it with matrices. So my first equation, 2x minus 4y, I'm going to subtract the 5z to get it to the other side, is equal to negative 1. For my second equation, I'm going to subtract the 2y and I'm going to add the 3z. So we get negative x minus 2y plus 3z is equal to 0 because in this case, there was nothing left on this right-hand side of the equation. My last one is already in standard form, so I'm just going to bring it over here exactly the way it is. Now that I've written my three variable system in its standard form, I can now convert it into a matrix form. So we are going to set up our coefficient matrix, then our variable matrix, and that is equal to the constant matrix. When I line this up here, the way matrices work, I'm going to do X, Y, and Z. So I'm saying the X's are all in this first row, the Y's are all in the second row, column, and Z is in the third column. So the X's are going to be in this first column, the Y's are going to be in the second column, and the Z's are going to be in the third. The way matrices multiply, it is this column times this row. So you do want to make sure that they are written out that way. So 2, negative 1, and 3 are my coefficients on the X. So there's my column. Then my Y's, that's negative 4, negative 2, and negative 5. My third ones here are going to be negative 5, positive 3, and negative 3. So my X's, my Y's, my Z's. In my constant matrix, I'm going to have negative 1, 0, and 14. That's the first step. You've got to get that correct for it to give you the correct answer. So we're just starting with that there. If you'll go ahead and pause the video, try and get these two written into the correct format, and then check your work. All right, so check your work. That's what you should have gotten for both of your setups. This one here was a little bit trickier. There was no z in that second equation, so you should have a 0 there as the coefficient, which is what made it have no z. So make sure that you got that correct. The setup is crucial because the calculator is going to be doing all the work for you as long as you get that setup correct. Now you should be asking yourself, well, now what? I have them set up in matrices. What's that going to do for me? So let's look at that. That's what we're going to do next. When you think about solving an equation that you've done previously, for example, this one right here, 2/3 x equals 8. In order to solve this, we would multiply both sides times 3/2. That's going to get my 2's to cancel here and my 3's to cancel here and get my x by itself. And so we would get x is equal to 12. What we did there is we multiplied times the multiplicative inverse. That's the multiplicative inverse of 2/3 is 3/2. The same is true for any equation you do. You multiply times the multiplicative inverse to get it to the other side. You always do that inverse operation. The same is going to happen with our matrices here. So we have A times X equals B. This is matrix A, this is matrix X, and this is matrix B. So if I want to get this X by itself, I need to get the A to the other side. So we multiply both sides times the multiplicative inverse. And so the -1 up in the top here, that stands for inverse. So we're multiplying times the multiplicative inverse, so it's going to cancel on this side. And we get X equals the inverse of matrix A times B. And this is what we're going to put in the calculator, because then we've solved for the variable X, or the variable matrix in this case. So here we go. We're going to write as a matrix equation first. So I get my X's, then I get my Y's, then I get my Z's. I put the X in the first column, the Y in the second column, and the Z in the third column, and it is equal to the constants 3, 11, and -8. Now we're ready to go. So we bring this one to the other side by doing its multiplicative inverse. So we get X, Y, Z is equal to the inverse of matrix A. So what that does is I'm going to put this matrix exactly the same, but we're going to say inverse by putting that little -1 on the top. That's going to tell the calculator the inverse of matrix A times my matrix B, which is the constant matrix. And then we plug this into the calculator using alpha zoom. And I want to show you how to do that. So we're going to do the steps right here on our calculator. We hit alpha zoom. Alpha zoom takes us to our matrix menu. And so it's asking you how many rows and how many columns. So we're going to start by putting this one right here. And so it has 3 rows and 3 columns. So we're going to put a 3 by 3 matrix. And so we put 2, -1. I'm using my arrow keys to get from one little point to the next. And I'm going to put it in exactly the way I see it on my paper here. So 3, 1, -2. You want to be very careful. Make sure that you put exactly what it says, because messing with one number or one sign is going to throw the whole thing off. So we've got 2, -1, -2, 3, 1, -2, -2, -1, 1. Perfect. Now we get out of our matrix here, and we're going to hit the inverse key. That is found right there to the left of sign. It's that key right there, X to the -1 power. That's the inverse. That's what that's showing there. And now we're going to do our second matrix, the constant matrix B. So we do alpha zoom again. And this time I want a 3 by 1. And so we put 3, 11, whoops, almost messed up that, and a -8. We verify that all the numbers are right, because again, the calculator does all the work. All you got to do is make sure that you have typed it in correctly. Now we hit enter, and it gives us our answer coefficient right there. And so what this is saying, we have X, Y, and Z is equal to 2, 3, and -1. So my X is 2, my Y is 3, and my Z is -1. So X equals 2, Y is equal to 3, and Z is equal to -1. Obviously, that's way easier than what we did last class when we solved algebraically. But you do have to know both ways in order to do it on the quizzes and tests, and to think through everything. If you can solve those, you're better for it. All right, we're going to do some more just so you can see another example here. We've got another example. They're all lined up correctly already, so we're ready to go. And so I'm just going to go ahead and have it X, Y, Z. is equal to my coefficient matrix, the inverse of it. So that's 1, 2, 4, -4, 3, 1, 3, -5, -1. The inverse of that one, it's always the inverse of that coefficient one. Then we're going to have our constants, -7, 19, 17. Once you have that written down, you're ready to put it into the calculator. One of the things the calculator does have, it's got like a copy paste. If you go and highlight it, you can hit enter and it copies and pastes it down for you so that you don't have to do that whole setup again. So if you're doing multiple of these, that helps out a lot. You use your arrow key to get back to the beginning here. Now just be very careful that you go over the entire number with the new number. So 1, -4, 3 here. Don't forget that 2 there. So little things like that, just make sure that you have checked the work. But you're going to keep going with your arrow key here and putting in all of your coefficients. And then you're going to come up here and put all your constants. So -7, 19, and 17. I like to, once I've put it all in, go ahead and check my work again. So I look to make sure that all of the numbers have covered them correctly. And I just caught a mistake on mine. So I'm going to go back there, delete that negative sign. Now we're all matching. So we hit enter and there's my answers there. So X is equal to 3.5, Y is equal to 1.5, and Z is equal to -1.5. All right, it's best if you try one. It's a lot of keys to press in the calculator. So go ahead and try this second one. Remember that if there's no X value, like in the second one, you do have to put a 0 as a placeholder for it. So pause the video, give that one a try, and then come back and check your work, and I'll have that one worked out for you. All right, here's what you should have gotten for that one. Again, you should have had a 0 for the Z in the first equation and a 0 for the X in the second equation. Once you put that all in, you should have gotten X equals 5, Y equals 1, and Z equals -6. Solving with matrices is a really good way to do it. Again, you need a calculator to do it, and you should still be able to do it algebraically. But there you go.